Broglie equation. It's on our conversion and equation sheet. Finally got organized around here so I can find my conversion and equation sheet. So the de Broglie equation is this equation right here. It says wavelength equals h over mv. So let me write that down and I'll talk about it. And this specifically is for calculating the wavelength of any matter, any particle, anything. And so you'll also sometimes see this referred to as, for us, wavelength of an electron. And I gotta turn off my email. Sorry about those dings if you can hear them. But let's do the wavelength of an electron since that's what it's asking about. It says, what is the wavelength of an electron traveling at 4.51 times 10 to the 5th meters per second in nanometers? And so here's how this goes. So h is Planck's constant, and Planck's constant is on this list somewhere. Right there. Planck's constant, 6.626 times 10 to the minus 34th joule seconds. And mass is going to be the mass of an electron. The mass of an electron is right here, 9.1 times 10 to the minus 31 kilograms, and that is the units that you need for this. And our velocity is v 4.51 times 10 to the 5th meters per second. Okay. And let's see. So now we just have to multiply all this stuff out. .626 exponent 34 minus divided by 9.1 exponent 31 minus divided by 4.51 exponent 5. I get 1.61 times 10 to the minus 9th. And if we look at our units are not exactly too clear here. We can see that our seconds cancel out because, do our seconds cancel out? Well, all right, so there's two things we can say here. One is, see this meters right here? It turns out that that's our units. It turns out that a joule is a kilogram meter squared per second squared. And so our kilograms we can see canceling. We actually have 2 seconds that end up canceling, and we're left with only one of the meters canceling, so we do end up with meters here. And our answer has been asked for in nanometers, so we will do a unit conversion here. 1 nanometer equals 1 times 10 to the minus 9 meters. And we get 1.61 exponent 9 minus divided by 1 exponent 9 minus. I get 1.61 nanometers. So the answer that you would want would be the 1.61. And the point of this calculation is not only to familiarize you with the de Broglie equation, but this wavelength of 1.61 nanometers, so a hydrogen atom has a radius, and we won't do this calculation, but it has a radius of 0.05 nanometers. And so the wavelength of an electron is larger than the size of a hydrogen atom. And if we were to do this calculation for anything other than an electron, anything with more mass than an electron, we would come out with a wavelength that is much smaller than the size of an atom and therefore not measurable. So that's the whole point of this, and why we're doing it is to show that the wavelength of an electron is bigger than an atom and therefore important when we talk about atoms. Any questions about that? Okay.